guys, in this video we're going to look at dot and cross diagrams for covalent compounds. And a covalent bond is simply defined as a shared pair of electrons, and these types of bonds are formed between non-metals. In order to do dot and cross diagrams, you'll need a periodic table and a pencil. The first step is to draw circles for each atom, and we write the element symbol inside each of the atoms. In our first example, chlorine, Cl2, chlorine is a diatomic molecule, that means it goes round in twos. We find chlorine, it's in group 7, that means it's got 7 outer electrons. And the number of bonds chlorine likes to form is 1. So it's going to form a single bond here where the circles or the atoms overlap, and we can represent that by a dot and a cross. Now we said that each chlorine has 7 outer electrons, so this chlorine can be the crosses 1, 2, 3, 4, 5, 6, 7. This chlorine can be the dots 1, 2, 3, 4, 5, 6, 7, and then we check that it's correct by making sure each chlorine has 8 electrons in its outer shell, which it does. And if you're doing chemistry at college, so that's A level or level 3 applied science, we only need to show the outer shells. In our next example, oxygen, we do the same thing. A circle for each atom, the element symbol inside the circle. Oxygen forms double bonds, and we represent that by 2 pairs of dot and crosses. There's our double bond. Oxygen's in group 6, so it has 6 outer electrons. If this oxygen is the crosses, we've got 1, 2, 3, 4, 5, 6. If this one's the dots, 1, 2, 3, 4, 5, 6. And then count them up so they add to 8, 2, 4, 6, 8. And each oxygen has 8 in its outer shell. The next example, carbon dioxide. Same thing again. Carbon likes to form 4 bonds, oxygen likes to form 2. That means that there must be a double bond in between each of the carbon and oxygens. So 2 double bonds. Dot cross, dot cross. There are double bonds. Carbon's in group 4, that means it has 4 electrons in its outer shell. 1, 2, 3, 4, and it's used them all in bonding, so there's no spare electrons left over. Oxygen, 1, 2, 3, 4, 5, 6, because it's in group 6, remember. Check it's got 8 in its outer shell. 2, 4, 6, 8. The carbon's also got 8. 2, 4, 6, 8. And put these electrons in for this oxygen as well. And our last example, methane. Hydrogen forms 1 bond, so we do single bonds in between each carbon and hydrogen. Hydrogen's in group 1. Sometimes it's shown in the middle of the periodic table, but it is in group 1. It's only got 1 outer electron. It's only got 1 electron in total, actually. So that's it for hydrogen. Carbon has 4 outer electrons. It's in group 4. And it's used all these in bonding again. So there's nothing left over. So that is methane.